Alright, you've been looking at limits graphically and limits with tables. This is solving limits with algebra, and the steps are before you. The first step is always to plug in the value they give you first. Don't do anything else until you try that, because you may be done. If you look at example 1, I want the limit as x approaches 2 of that equation. I plug a 2 in and do the math, I get 19. I'm done. That is the limit. Example 2, however, the limit as x approaches -3, I plug a -3 in for all of these x's, do the math, and I wind up with 0 over 0, which is an indeterminate state, or undefined basically. So we're not done. We have to do something else. And our first thought is to factor. So we can factor the top out, x plus 3, x minus 2. Factor the bottom out, x plus 3, x minus 3. And you know from factoring experience that if you have the same term on top and bottom, you can cross that guy out. He's a whole. And what you're left with, you can re-evaluate. Step 2 is always to re-plug in that c value. So re-evaluate what you have left right here. Plug in that -3 in for both those x's. Do your math right here. -3 minus 2 is -5. -3 minus 3 is -6, giving us an answer of 5, 6. Our limit is 5, 6 in this case. Example 3, again, plug a 0 in for all the x's, and you're dividing by 0. That is undefined. You can't do that. And you can't factor that one. But it could be solved with conjugates. So multiply the top and the bottom by the conjugate of the square root of x plus 5 minus square root of 5. Right here. Okay? Distribute, combine like terms, and we wind up with x plus 5 minus 5 on top, times x times the square root of x plus 5 plus the square root of 5 on the bottom. These x's right here will cross out. Those eliminate to begin with, leaving us just x on top, and then that x crosses out on the bottom, leaving us with 1 over 2 square roots of 5, because we're going to plug that 0 in right there to eliminate him. Remember, step 2 is always to re-plug that c value in when you get your expression and simplify it down. So this limit is 1 over 2 square roots of 5. Finally, we have the idea of example 4 here. The limit as x approaches 2 of a absolute value function. Plug your 2 into both of those spots and you get 0 over 0, which is again undefined. So we have to do something else. We can't factor it. We can't conjugate it. But absolute value functions can always be rewritten as a piecewise function. So the absolute value right there, when you're talking about negative numbers, they're going to be turned positive. So we can rewrite this whole fraction as negative x minus 2 divided by x minus 2 for all the values that would make it negative, because the whole point of the absolute value is to make negatives positive. That negative sign is going to make all those negatives positive. For x greater than 2, we have just the expression in front of us, because all of those will be positive. We don't have to worry about any negative signs. Just x minus 2 over x minus 2. And you can always rewrite an absolute value function this way, with the first piece being negative and the second piece being positive. Over here, these are our constraints. All right. Left of 2, we want to use a negative sign. Right of 2, we want to use just the expression here. And equal to 2 is not possible because that would have us dividing by 0. So with these expressions, you can take the limit from the left-hand side. This is the left-hand side. Well, x minus 2 divided by x minus 2 would be 1. Think about it. The same term on top and bottom, you divide them out, that would be 1. And because of that negative sign right there, it's going to be a negative 1. The limit from the left-hand side is negative 1. From the right-hand side, we're going to look at just this guy. Well, x minus 2 divided by x minus 2 is going to be 1. In this case, positive 1, because we have no negative signs to worry about. So that's him right there. Therefore, the limit from the left-hand side does not equal the limit from the right-hand side. That's supposed to be a does not equal sign right there. Does not equal. So therefore, the limit does not exist.